Here we are studying on-off based AC voltage controller. So here we can see, here we are connecting primary secondary of a transformer. So here you will see secondary of a transformer. This is coming from a secondary of a transformer. Okay. So whatever power is given here is AC. Its mathematical model is Vm sin omega t. Sin omega t. Yes. It is passed through two SCRs. Okay, one gate pulse we need to connect in between gate and cathode of this SCR. Another gate pulse we should connect in between gate and cathode of this SCR. Here two SCRs are connected in anti-parallel. This conducts in positive half cycle, this conducts in negative half cycle. Okay, and here we are shown a load. Here load is R load. In this, the technology is in this way. Here we have shown the inputs. So this is omega t. Here, yeah, this is your source voltage. My input is changing sinusoidal Vm. So this is maximum value is Vm. Its maximum value is Vm. Input is changing sinusoidally. Yes, this we have seen already. In positive half cycle, we apply gate pulse to this transistor. This is shown here using this gate pulses. This gate pulse, where we apply in the beginning of the cycle, in the first half cycle, we apply the gate pulse. Okay, because of that, this SCR conducts. It is acting like a conductor during entire positive half cycle. So entire positive half cycle is given to your load. Okay, so that's the reason the output voltage we are seeing here, we are seeing like this is sinusoidal for complete half cycle. Then in the next in the negative half cycle of the negative half cycle, in the beginning of the negative half cycle, we apply gate pulses to thyristor T2. Okay, here we are shown here. That's the reason T2 is conducting. It is acting like a closed switch. So current right now is flowing in this way. Is current like at the negative half cycle. This side is positive. This side is positive. So current is flowing in this way. Is flowing in this way. Flowing in this way. In this way. Through thyristor T2. So in negative half cycle also load receives the, this is a load is receiving the current, but it is in the opposite direction. Okay, that's the reason negative voltage is developed, as I have shown here. Negative voltage is developed. Okay, so in this way we turn on SCR thyristor T1 and thyristor T2. Again in the next half cycle we apply gate pulses to thyristor T1. We turn on this thyristor T1. So for entire duration the current current is flowing. That's the reason we are observing a load voltage like this. In the second half cycle negative, in the second cycle negative half cycle, we we need to turn on T2. For that reasons we are applying gate pulses here. So gate pulses here. So for entire negative half cycle we are observing the load voltage in this way, in this way, or else we are saying that we are transferring the power to load. But in the third cycle, okay, at the end of this half cycle both thyristors are in off state right now, correct? We are not applying gate pulses in the next cycle to T1. So what happens? The next half cycle input is in the next positive half cycle. T1 is also not conducting because we are T1 is not conducting because we are not applied any gate pulses. So load is not receiving any current from this source. So no load voltage, or else I can say that the load voltage is 0. Again in the next cycle, we have not applied any pulses to T2. So this is acting like an open switch. So load is not connected to source. So load is not receiving any voltage. That's the reason no voltage across the load. So 2 half cycle we have passed to loads and 1 half cycle we have blocked. Means in the two complete cycles we have passed currents to load, or else I can say that load has received the input voltage. For a 1 full cycle we have not passed any currents to load, so load has not received any voltage. So load voltage for 1 full cycle is 0. Somewhere here it is 0. For this cycle we have seen complete cycles. Like this it continues. Okay. So this is on-off based power AC voltage controller method. Here if I can, here 2 cycles we have turned on SCRs and for 1 cycles we have not turned on SCR. Okay, same thing we are going to repeat. For next 2 cycles we will turn on SCR T1 and T2, T1 in positive half cycle, T2 in the negative half cycle, so that we will pass the voltage for next 2 half cycles to 2 cycles to load, and for next 1 cycle again we will block the current, so we don't give supply to load. Same thing we repeats. In this way, for m cycles, so here it is 2. Generally I can say that here in this case 2 cycles we have passed the voltage, 1 cycles we have blocked the voltage. Okay, I will say this number of cycles we are going to pass the voltage to load. Here onwards I will call as n. Okay, onwards I will call as n. Okay, number of cycles we have blocked the supply to load is you call as m. Okay, here m is 1, n is 2. What is total m plus n? M plus n is 3. Thing is, out of 3 cycles, 2 cycles we have passed to load. Same thing we are going to repeat. Means for the next 3 cycles, 2 cycles we will pass supply to load. For 1 cycles we will block. So in this way we are controlling the load voltage. You can see here, if I say, if this is an input voltage and this is an output voltage, the RMS of the output voltage is less than the input voltage. So assume that we want more voltage, means what we need to do here, you can see how many. So okay, next we will derive the formula for the RMS value of the output voltage. RMS formula for the output voltage, that is what? Root. So root mean. So see here, you can see here which is a periodic waveform, here to here, here to here, and here to here. So this is a period of the waveform. This is a period of the waveforms. In this case it is here to here it is 2 pi, here it is 2 pi to 4 pi, here 4 pi to 6 pi. So actually here from here to here it is 6 pi. Generally I will say 6 is 6 pi, correct? 6 pi means 3 into 2 pi, actually it is 3 into 2 pi. So what I will say here, m plus n 2 pi root mean is over square. So this is Vm sin omega t. So right here Vm sin squared omega t d omega t. So one is 0 to 2 pi. Okay, then we should integrate next part also, here to here it is 2 pi to 4 pi Vm squared sin squared omega t d omega t. So this is 4 pi to 6 pi Vm squared sin squared omega t d omega t. The next in this case only 2 is there, correct? Yeah, this part is not there, this part is not there, 2. So this is how much? This is 0, this part is C. Okay, so only 2 part is there, that 0 I don't need to consider, only this 2 part is there. Okay, so we can see here Vm squared, here also Vm squared. So if you are integrating from 0 to 2 pi this part and integrating 2 pi to 4 pi this part, strictly speaking both are giving same answer. So that's the reasons I can rewrite like this. I will show you that why it is giving same. So here it is 2, so actually 2 divided by m plus n 2 pi root of 0 to 2 pi Vm squared sin squared omega t d omega t I can write. So in this case too, generally assume that we are turn on this SCR for n cycles and we turn off for m cycle. Means in this case what is m plus n is 3. So n is 2, m is 1. So general term is, generally I will rewrite like this, n by m plus n 2 pi to this. So this we have several times we did integration of this. So I can Vm squared I can keep outside. Okay, I will show you. See here, for an example, if you turn on for 3 cycles, means this is 1, again 1 more cycle I will turn on, and if you think that some more cycle I will turn off. 3 cycles I will turn on and 1 cycle if you turn off, how it looks like? So 1 by 2 pi, this 2 pi I should write I should rewrite like this, m pi to 2 pi Vm sin omega t d omega t. See here what I am saying, here to here Vm this. So here to here pi to 2 pi, here pi to, so what I should correct, tell me. What is the mistake here? This is pi to 2 pi, then this is 2 pi to 4 pi. This is, or if you are considering only two terms, okay, you no need to because in the previous I shown only two terms. Okay, delete this part. Okay, so then we are considering 2 cycles on, 1 cycle off. Okay, so we can see here Vm squared I can keep outside, m plus n pi 1 minus cos 2 omega t, then again this sin squared omega t, same thing. You can see here this term and this term is same almost. This is from pi to 2 pi, this is from 2 pi to 2 pi, and if you simplify, 1 becomes omega t pi to 2 pi, cos 2 omega t sin 2 omega t by 2 pi to 2 pi, 1 becomes omega t 2 pi to 4 pi, again this is sin 2 omega t 4 pi to pi. Okay, this I will delete it. So next, now you can see here this term and this terms are both are same, because 2 pi minus pi sin 4 pi by 2 sin 2 pi by 2, this is again 4 pi minus 2 pi. Okay, so 4 pi minus 2 pi sin 8 pi by 2, this is how much, 2 pi, this is 0, this is 0, this is 2 pi, this is 0, this is completely 0, this part is 0. So here also we got 2 pi, here also we got 2 pi. If you are having only 2 cycles, twice we will get 2 pi. So if I am having n cycles, how many times I will, if I am having n cycles, how many times I will get 2 pi? That simplified part is here, it is twice I got 2 pi. So if it is n cycles on, then I will get n pi. What I am saying, all these parts, this integration parts, pi to 2 pi this integration, and 2 pi to 4 pi this integration, and if for any number of times, if n is 3, again 6 pi to 4 pi to 6 pi, n is 4, 4 pi to 8 pi. Okay, any times if you integrate, the sum is n into this. If you are integrating 4 times, 4 into this, 3 to this. Okay, that's what I am saying. So what I am saying here is we will get finally answer as instead of 2, I will get n pi here, n pi here. What I am saying, instead of doing like this, instead of wasting my time, initially I will, instead of, if this is for n cycles, instead of writing this n times, easily I will write n here, n I will write n here, and I will delete this. Okay, so then what happens, so there is a n term here, okay, pi, so you just delete this. Okay, okay, so this plus is not required. Okay, so then there is a n here, there is a n here, okay, so this part is not there. Okay, So this is also not there. So n here, n is there here. So this part is not there. So n is here, so only this part is there. This is 2 pi. So what happens now? This is 2 pi, this is 2 pi. There is no mistakes. Let's see. Here 1 2 is there, no? Yes. So this is 2. This is 4 because this 2 has complete 4. This is 4. So here you are having I'll say 4. 4 I will write, okay, 4. So remaining is 4. 2. So this is only 2 pi. 2 pi. So 4. So 2 cancel each other. M by 2. 1 by sin pi. This is number, because these 2 cancel each other. Okay. So Vm by root 2. Vm we have kept outside. This only 2 is these 2 cancel with this 2, so 2 is remaining. That 2 I will keep outside. So this pi and pi cancel each other. So n is there here, n is there here, n is there. So n is there. So what is an answer? So answer is only this, Vm by root 2. Okay, so answer is Vm by root 2 and this part. What is Vm by root 2? V source RMS to n into n plus n. So what I am saying here, Vrms of the load is V source RMS into n by m plus n. If you change the n values, if you keep constant, because m plus n, for an example, if you keep m plus n is 8, and if you n is 4, if you choose 4 by m is 4, n is 4, 4 by 8, root of half. So if you choose n is 1, m is 3, so 1 by 4. If you choose n is 3, means on cycle is 3, off cycle is 1, and n is 3, means 1 by 4. So by changing n and m values, so by changing n values, I can change the source RMS. Means, so by changing the number of on cycles, I can change the total RMS of the output which we are delivering. This is on off cycles, very simple. So I can show you. So instead of writing like this, okay, I should have written here. So this is better. See, easily you can start. So because what I am saying, n cycles we will turn on. That's the reasons we write like this: pi into 2 pi Vm sin omega t n. Okay. So this is a starting equation, n by m plus n 2 pi. Because what is the total time here? See, total duration is m plus n into 2 pi. Out of that, n into these many cycles we are integrating. Okay, I can show you again, so please go through that. This simple 1 minus cos 2 omega t pi to 2 pi to 2 pi, this. So this is very simple principle. So assume that 10 cycle we are having, 7 cycle I can pass to my load and 3 cycles I will block. Again in the next 10 cycle, first 7 cycle I will pass to load and last 3 cycles I will block. So to pass to the loads, in positive half cycle I should fire this, in the negative half cycle I should fire. To block, so I should not apply gate pulses to this in positive, I should not apply gate pulses to this in negative. So here orally I will say that out of m plus n cycle, n cycles will pass the voltage to load, m cycles will block the load from supply. So in this case we have shown n is 2, m is 1. So if you derive like this, instead of writing n times, what I am writing? I am writing n by m plus n 2 pi 0 to 2 pi. This itself I will take as a starting condition and I will derive as I have shown here, Finally I will get formula like this. This is applicable for all heating coils and all. This kind of method is possible because it is having very high time constant. So for heating coils especially, in this way we are changing the load voltage. We can control the RMS of the load voltage in this way. This is on-off based methods. Thank you.